Hello, and welcome to my presentation on algorithm identification in source code of programming assignments. I am Pranshu Chaurasia from IIT Bombay, India, and I am presenting joint work with Suraj Kumar, Ganesh Ramakrishnan, and Varsha Apte. The outline of my talk is as follows. We'll begin our presentation by understanding the need of an intelligent autograder. Then we will present approach of our algorithm identification and so on. The conventional autograder work on a test case-based approach, comparing the output of a code to a predefined outputs. This setup is good for a competitive coding. But for educational purposes, instructor may have some different source code requirements, such as specific algorithm implementation using a specific data structure, etc. But existing autograders fail to ensure such source code requirements. Hence, there is a need of an intelligent autograder that understands the codes and grades it. The specific goal of this work is to design a system to identify algorithm being implemented in the source code, which carries out a given functionality correctly. Example, sorting and searching. The input to the source input is a source code, and the output should be the correct label of the algorithm implemented in the source code from a set of already known algorithms. An additional goal for the model is the explainable system that should be able to explain its prediction. For our model, the work started with a basic similarity detection software called MOS, whose prediction accuracy was around 66%. This was taken as a baseline for any model prediction. Later, we explored machine learning-based models by incorporating SVMs along with tree and graph kernels, which are supposed to determine the similarity between code structures. But this approach also gives a maximum approximate accuracy of around 85%. This is also roughly accuracy limit achieved by some previous ML approaches based on statistical features on the source code. To push our accuracy higher, we started exploring transformer-based architecture model and decided to use CodeBird, which is a bimodal transformer encoder model, which takes contextual embedding under the consideration, and Graph CodeBird, which is a transformer encoder-based model that takes contextual embeddings and the data flow information under consideration, and fine-tune it for our algorithm identification task. The algorithm identification model is trained on C and C++ dataset crawled from ISO Online Church, further splitting the test and training data. The stats for each algorithm used are as shown in this figure. The model pipeline starts with tokenizing and labeling the crawl dataset and feeding directly the tokenized data into the CodeBird model. While for Graph CodeBird, tokenized data is also used for generating AST using presetter module and then converting into data flow information using parser and fed it into the model. The results of both the models were 100%, which seems practically impossible and too good to be true. Therefore, we decided to use a LIME model for explaining the classifications. We configured LIME for CodeBird and the Graph CodeBird transformer models, and the result shows that the model is focusing too much on the function name, which is in general similar to the implemented algorithm. To test, we purposely changed the function name of a bubble sort program to an insertion sort, and as a result, our model prediction fails and classifies the code as an insertion sort, giving significant importance to the function name, insertion sort. Hence, we conclude that model is biased towards function names, which are much easier for a model to learn rather than complex code structure. So the key idea we come up with was scrambling, a scrambler module for preprocessing the input by replacing all the identifiers and user-defined functions and names with random strings, keeping syntax and semantics intact, making the model more robust and generic towards its prediction. Sample Scramble code is shown below. The results after the Scramble module shows an unbiased model correctly predicting labels, focusing more on semantics rather than function names. The final performance results of CodeBird shows a variation of 90 to 99% accuracy among the three sets of algorithm, which earlier was 100% due to bias. Results of Graph CodeBird shows the variation of 96 to 99% accuracy for the three sets of algorithm. Some keys or observation for the bubble sort code shows that the bubble sort code focuses more on array name, inner looping variables, and temporary variables, which are used for swapping, are the key indicators for the bubble sort. For other algorithm, indicators are mentioned in the paper. Even after attaining certain enhancements, there was a persistent problem of incorrect labeling in obfuscated code. An example of which is that the code contains 2 or more functions, and out of which the main calls only one function. In the figure, as per the code, the label should be bubble sort, but the model fails to predict this. The key idea to deal with such obfuscation is static code elimination module, which removes unreachable function from the code. As in the figure, count_sort function was unreachable and was removed by this module. This brings us to our final updated pipeline, starting with crawling dataset for 3 sets of algorithms, followed by static code elimination module, which in turn followed by a Scramble module. The Scramble code is then tokenized and labeled. The rest of the model remains same as the previous. Finally, concluding, we presented algorithm identification results using preprocessed data on CodeButt and Graph CodeButt, which give high accuracy for the datasets on which it was tested. Also, usage of line explainer model to generate insights. Future work may include dealing with more sophisticated forms of obfuscation, instruction-wise and dynamic code elimination, and finally, widening the scope of various programming tasks like identifying recursive versus iterative and different programming styles and paradigms, etc. Thank you. That's all from the presentation. Have a nice day.